The military recently developed an augmented reality headset called Eagle Eye. It gives operators a live tactical minimap and literally lets them see enemy combatants right through solid walls. Usually, building an interface like that requires hardware like the Apple Vision Pro, devices packed to the brim with bulky LiDAR scanners, depth sensors, and complex 3D tracking arrays. But a creator named Bilawal Sidhu recently replicated this exact see-through walls effect using off-the-shelf $300 Meta Ray-Ban sunglasses. There is an obvious physical problem here. These glasses are essentially just a pair of dumb cameras strapped to your face. They completely lack the environmental sensors required to calculate depth or room geometry. To achieve military-grade spatial awareness on cheap consumer hardware, you have to bypass the physical sensors entirely and rewrite how the system calculates 3D coordinates. The immediate assumption is that you could just track the wearer using GPS, the same way your phone routes your drive to work. But standard satellite navigation is incredibly coarse. It has a rotational margin of error of 20 to 30 degrees, and the signal degrades heavily the moment you enter an urban corridor. Worse, satellite signals drop dead inside a building. Anyone who has watched their blue dot violently bounce across a map while waiting for a rideshare knows this. GPS gives you a vague radius, but zero accurate elevation or floor-level data. Because satellite systems are blind to your immediate indoor surroundings, rendering an accurate augmented reality overlay demands a localized tracking system capable of centimeter-level precision. The solution to the missing hardware is a software protocol called a Visual Positioning System, or VPS. This diagram illustrates the first step. You start by taking a standard smartphone camera and panning it around a physical space. The system analyzes that video to pre-compute a highly detailed 3D map, creating a digital twin of the environment. Next, you take the live 2D video feed from those standard Ray-Ban glasses and stream it directly into the system. By constantly matching the incoming pixels from the video feed against the pre-scanned 3D model, the software instantly calculates the exact coordinates and viewing angle of the glasses. You get highly accurate 6 degrees of freedom tracking without LiDAR. The heavy computational lifting is shifted away from expensive hardware on your face and into the pre-computed software map. This diagram shows what happens when you introduce a second camera. If someone else pulls out their smartphone and connects to the exact same pre-computed map, both devices are now anchored to the identical coordinate system. Because they are sharing that spatial web, the phone automatically knows the exact XYZ coordinates and orientation of the person wearing the glasses, even if they are standing on the other side of a solid wall. To visualize this, the software simply renders a stick-figure avatar at those shared coordinates and overlays it directly onto the phone's live camera feed. It looks like X-ray vision, but it's an illusion. You are viewing a synchronized spatial database shared between two completely ordinary cameras. If a simple software protocol can turn cheap sunglasses into a spatial tracker, you can apply that spatial intelligence to literally any camera lens. On an offshore oil rig, a utility worker can walk up to a piece of complex machinery and immediately see permanent, floating 3D maintenance checklists anchored to specific valves and gauges. Inside massive, labyrinth-like airport terminals or shopping malls, localized pixel tracking provides centimeter-accurate 3D wayfinding directly on your screen. And in active conflict zones where GPS signals are actively jammed or spoofed, military drones can use their own downward-facing cameras to match ground pixels to a map and navigate autonomously. The true power of VPS is taking isolated devices, from consumer smartphones to autonomous vehicles, and standardizing them onto a single, globally verifiable 3D coordinate system. But the same system that allows a utility crew to track their equipment also introduces a massive surveillance vulnerability. Commercial building owners can weaponize these pre-computed maps to monitor human behavior. By tracking the localized position of every device, they can generate spatial heat maps to see exactly where people dwell and record the specific physical direction of their gaze. Right now, enterprise companies rely on strictly controlled, highly secure private VPS deployments to prevent that data from leaking. But simultaneously, massive tech companies are driving camera-equipped vehicles down public streets to build enormous, publicly accessible spatial databases. The trajectory of augmented reality over the next 5 years points entirely away from the physical headsets we wear. The ultimate winner of the spatial computing market won't be the manufacturer of the most expensive optical sensors. It will be the entity that owns the foundational 3D map of the world.